In this video, we're going to look at section 7.4, page 99 of your workbook, special products. So we've been learning about in chapter 6, when we multiply binomials, we will get some special products, difference of two squares, and perfect square trinomials. So now we're going to look how to reverse the process and to factor those. So if we have something that is a difference of two squares, a squared minus b squared, then we can factor it as a plus b times quantity a minus b as two binomials. The sum of two squares is not factorable. So let's just make a little note there. Note that a squared plus b squared is prime, we could say, or not factorable. So if you see a sum of two squares, then you're not going to do anything. You're just going to write prime or not factorable. You don't want to leave it blank though. Now, if we have the difference of two fourth powers, we have a to the fourth minus b to the fourth. That means we're going to get a sum of two squares here, which isn't factorable, but we would have the square root of the first. How this breaks down, let's see. We would actually have a squared plus b squared times a squared minus b squared. But then that a squared minus b squared breaks down again to be using the difference of two squares format, a plus b times quantity a minus b. And I would say that's a pretty common mistake that people don't continue on and then factor again. Now leave this one, it can't be factored as we talked about, just leave it, rewrite it. But the a squared minus b squared right here, for sure, that can be factored. The other case we'll get is perfect square trinomials, where you have a square as your first term and a square as your last term. And then in the middle, if you were to multiply the square roots of each of those together and double it, you would have the middle term. So if we have something of this situation, a minus b all squared, that would be how we would factor it. So we have a squared minus 2ab plus b squared. That would be a minus b all squared, or a minus b times a minus b. Same thing if we have a plus here, then we're going to have a plus in the middle. A squared plus 2ab plus b squared equals a plus b times a plus b, or a plus b all squared. And one thing to really note here, again, is that, and we looked at this in chapter 6, but that a plus b all squared is not equal to a squared plus b squared. Okay, as we just noted here, that's not even factorable, so we wouldn't go that direction at all. So I want you to take a look here at the first one, 7.25. Example, a is p squared minus 81, and it says factor using the difference of two squares formula. So we would have the square root of the first one plus the square root of the second one as a binomial times square root of the first one minus square root of the second term as a binomial in parentheses. So you don't have to write this out every time. I'm just really want to stress what I'm doing for the lesson. But now we would take the square root of p squared. So we would have p plus square root of 81 would be 9 times quantity p minus 9. Then we're going to check. We're going to mark our answer, but then we're going to verify. That's really important. So we would do the first would be p squared outside minus 9p inside plus 9p, and then out or last is minus 81. These go to 0, so we do in fact get p squared minus 81 as our answer. Now for part B, it's a little bit different. You can, it's not the fourth power. It's not 2 fourth powers. It's 1 fourth power and 1 square. So we're not going to follow this pattern that we were just looking at of a to the fourth minus b to the fourth. So just don't assume, make sure you look at the powers. So what we're going to do though is take the square root of the first one, which is 5a squared, add the square root of the second one, which would be 3b, in parentheses, times parentheses, square root of the first one again, 5a squared minus, remember we have to have opposite signs. If we don't have opposite signs, we're going to end up with a perfect square trinomial, not a difference of 2 squares. So minus the square root of the second one, which is 3b. So that's our answer. We're going to check or verify that we would get, in fact, first would be 25a to the fourth. Outsides is minus 15a squared b. Insides is plus 15a squared b. And last is minus 9b squared. These go to 0, so I am good. It works. So for example, 7.26, we have the difference of 2 fourth powers. So we're going to use that. You may not recognize these as a fourth power, like 256 as a fourth power right away, or even 81 for that matter. So your clue is that you have x to the fourth here, so you can check. You can just see. Just use your calculator and see if you can find the fourth root. But it is good to get familiar, so maybe looking at a chart of some sort or just playing around in your calculator so you kind of can recognize them as you move up on through math. That would be expected. So on the first one, we're going to take the fourth root of this first, actually I'm just going to do it as the square root first. I'm going to take it in a couple of pieces. So I'm going to split it apart as 9x squared plus 16, because I can recognize the difference of 2 squares easier than the difference of 2 fourth powers. So I would have then 9x squared minus 16. And now I notice I need to keep going. So I don't necessarily use the formula per se that they use there. So this one just comes down. It's the sum of 2 squares, not factorable, so just rewrite it. This one is the difference of 2 squares again, so I would have 3x plus 4 times 3x minus 4, and that's as far as I can go. And then you would verify just using the same process that we had before. Okay, this is a pretty short section, so I'm just going to stick to one video here. So next we have 7.4.3 perfect square trinomials. And we're going to look at example 7.27, factor using the perfect square trinomials formulas. So I'm going to rewrite those back up here. We have a squared plus 2ab plus b squared equals a plus b squared. Whoops. And then we also have a squared minus 2ab plus b squared equals a minus b all squared. So what we want to notice, how you can pick up on this, is that you have 2 squares on the end, an x squared and a 9, right? So I have perfect squares and I have a middle term. So let's check to see, is the square root of the first, which is x, times the square root of the second, which is 3. If I double it, right, is that equal to my middle term? So this is 2ab, and that actually does equal a positive 6x. So yes, it's equal. So it's a perfect square trinomial. So you have to first check for that. And then you can just simply take the square root of the first. It's a plus in there. So plus square root of the second, and square it, and you are done. So those are nice, but do make sure you do the check here. So we would have x plus 3 times x plus 3. That's two binomials, and I would have x squared plus 3x plus 3x plus 9, and I do get my middle term of 6x. So double check. Now this next one, part B, same idea, except we have a subtract in the middle there. So we have to account for that. And again, we're going to test it first. What is 2ab? Okay, we have 2. A is 7a. That's the square root of the first term. Square root of the last term would be 2b. So in this case, we actually have to count that we have a negative here. So if we have a negative there, we're going to say that we have a negative in the middle there somewhere, right? So we would have, or actually it's going to be the second one, right? The last one would be the negative. So we're going to end up with a negative 14ab doubled. So that would be negative 28ab. So it fits. It is a perfect square trinomial. So then we can take the square root of the first. And then we're going to subtract, though, because this middle term is subtract, minus 2b all squared. And then again, you would check it. Make sure you do the check. And that's what the check looks like right here. And so if you can figure out how to do these two types, that's perfect for the scope of this course. I am going to show you one more thing here, though, where we have a greatest common factor that we can pull out first. So we have a couple of steps to do. And I think you could do this as classwork. So go ahead and try it. But remember, you got to pull out a GCF because out of all three of those, there's something common. Actually, I'll do this first one if you want with me. To do it with me. So we would pull out a 2 and we would be left with 9n squared plus 30n plus 25. Now we can still factor what's inside here because if we know we have a perfect square trinomial, because we would have 3 times 5n would be 15n, and double it, we get the 30. So we can use our 3n plus 5 all squared. Same thing for here. If you look, you can pull out a greatest common factor, 2y, and that leaves us with x squared minus 6x plus 9. We have 2 squares on the ends. If we take the square root of each of those and double it, then we will have a perfect square trinomial. So I know I can factor that. But be careful here. I have a middle term that's negative, so I'm going to do x minus 3 all squared for that one. And again, do your checks, verify it, make sure you get what you started with. For this sum or difference of 2 cubes, we might look at that briefly in Math 1 or 99 is what you guys will be taking. We change the numbers. So later you'll be looking at this. So for now, we're just going to skip it. A lot of professors never do it at all. I touch on it very briefly in Math 99, but not everyone will. That's kind of one of those optional things. It's not highly critical. If it does become something you need later on, it's really easy to pick up. It's just a formula. You can also do it by long division that you'll learn more of later. So that is it for this section. And the homework should go pretty quickly on this one too. So have a great day.